Expressions. Simplify expressions when adding or subtracting. What are they? A sentence is a minimum of two numbers in at least one math operation. Why? Helps in finding relationships. Interesting fact, Antarctica and a few remote islands are the only places with no indigenous ants. Now here are the examples we're going to be talking about in today's video. So let's take a closer look at example 1. Now let's read the steps. Step 1, rearrange the terms. Step 2, combine like terms. Now let's read the question. Simplify the algebraic expression 4ab plus 3ab plus y. Now we're going to go ahead and color coordinate the terms so we can figure out which ones are the same. As we can see, we have ab written twice. Now in order to combine them, we need to either add or subtract. In this case, we're going to add the two numbers in front of the variables, 4 plus 3, that gives us 7. So now we have 7ab plus y, and that is our answer. Another way of doing this is to write it out individually. So we have 4ab, we can rewrite that as 1ab 4 times. Why 4? Because of the number 4. Now let's take a look at the next term, 3ab. We can rewrite that as 1ab 3 times. Why 3? Because of the number 3. So if we add all those ones, we get 7. The same number in our answer. So that is why you can do it either way, and you're still going to get the same answer of 7ab plus y. Now let's take a look at example 2, where we have 2ax minus y plus 3xa. You may be wondering, do we have any like terms in this scenario? And yes, we do. Ax and xa are the same. And why is that the case? Well, let's think of a small example in multiplication, where we can see 2 times 5 is equal to 10, and so does 5 times 2. So both of those equal to 10, and it didn't matter the order. So that is why, because we're multiplying those two variables, it doesn't matter the order, you're still going to get the same answer. And so we're just going to go ahead and rearrange xa as ax, and we can do that because of the commutative property of multiplication. And now we're going to rearrange the terms so the like terms are closer together, and we can do that because of the commutative property of addition. And so now we need to combine the like terms, and in this case we're going to add them. So we have 2 plus 3, that gives us 5, and so now we have 5ax minus y, and that is our answer. Now we can do the same thing we did in example 1, write them out. Let's go ahead and do that. So we have 2ax, we're going to rewrite that as 1ax 2 times. Now we're going to do the same thing to 3ax, we're going to rewrite that as 1ax 3 times. If we add all those ones, we get 5, the same number in our answer. So it doesn't matter which way you do it, you're still going to get the same answer of 5ax minus y. Now let's take a look at example 3, where we have 2xy squared plus y minus 6xy squared plus 6y. So let's go ahead and color coordinate the terms so we can see which ones are the same. Now let's rearrange the terms so the like terms are next to each other. And we can do that because of the commutative property of addition. And now we're going to combine like terms. In this case, we have, we'll take a look at the numbers in front of the terms, specifically xy squared. So we have 2 and negative 6. And so when we combine them, we're going to subtract 2 minus 6. That gives us negative 4. So now we have negative 4 xy squared plus y plus 6y. Now, you may be wondering, how do we add or combine the terms with the y's? Well, let's add the hidden number 1. So if the variable is by itself, we can just put the 1. Usually you do that mentally, but here we're going to show it on the screen. So we have 1y plus 6y. Now we're going to go ahead and combine them by adding the numbers in front. So we have 1 plus 6 is equal to 7. So now we have negative 4 xy squared plus 7y, and that is our answer. Now let's take a look at our last example, where we have negative 3x squared y plus 2xy squared plus 6x squared y minus 4xy squared. You may be wondering, do we have one like term? Well, although they look similar, they are quite different because of the exponent too. The exponent is in different locations. So we're going to move these terms so that the like terms are next to each other because of the commutative property of addition. And now we're going to go ahead and combine them, specifically the numbers in front of the variables. And we're going to look at the first two terms, and we're going to have negative 3 plus 6, and that gives us positive 3. And now we're going to do it to the next two terms, or next two like terms rather. And so we have 2 minus 4, and that gives us negative 2. So we have 3x squared y minus 2xy squared, and that is our answer. Now let's go ahead and you get a shot. So go ahead and pause the video so you can take your time to answer these questions. And I will show you the answers in 3, 2, and 1. Here you go. If you got them correct, well done. If not, there's always tomorrow.